4-wire installation is required from the meter main to the new panel for several reasons. Firstly, ground fault protection is paramount. A 4-wire system provides a neutral return path for ground fault currents, which are crucial for protecting against electrical shocks and fires. Secondly, harmonic mitigation is an important factor. Modern electrical equipment, such as variable speed drives and electronic devices, can generate harmonics that can interfere with electrical circuits. A 4-wire system helps mitigate harmonic distortion. Even though there may not be any other metallic paths between the house and the pole, the overhead triplex cable requires a 4-wire installation for the following reasons. 1. The neutral conductor. The triplex cable contains 3 conductors, 2 hot conductors and a neutral conductor. The neutral conductor is essential for grounding and harmonic mitigation. 2. The grounding electrode. The neutral conductor is bonded to the grounding electrode at the meter main, providing a low impedance path for fault currents. This protects against dangerous voltage buildup in the event of a ground fault. Therefore, it is recommended to install a 4-wire overhead triplex from the meter main to the new panel. This will ensure proper grounding, harmonic mitigation, and safety. It is important to verify the capacity of the existing transformer on the pole to handle the increased load. Comply with all applicable electrical codes and industry standards. Obtain necessary permits and inspections from the local authorities. When upgrading an electrical service, several factors must be considered to ensure safety and compliance with electrical codes. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including service upgrades. Understanding these requirements is crucial for a successful and safe upgrade. The size of the service entrance conductors must be adequate to handle the expected load. This is determined by calculating the total load of the dwelling, including lighting, appliances, heating, and air conditioning. NEC Table 310.15b16 provides ampacity ratings for conductors based on their size and insulation type. It is essential to select conductors with an ampacity rating equal to or greater than the calculated load. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect conductors from overloads and short circuits. The overcurrent protection device must be sized appropriately for the conductor ampacity. NEC Section 240.4b provides guidelines for overcurrent protection. Grounding is a critical aspect of electrical safety. The grounding system provides a low impedance path for fault currents, protecting against electrical shock and minimizing the risk of fire. The grounding system consists of a grounding electrode, such as a ground rod or water pipe, connected to the neutral conductor at the service entrance. NEC sections 250.50 through 250.68 provide detailed requirements for grounding electrodes and grounding electrode conductors. Bonding is the process of connecting all metallic parts of the electrical system to the grounding system. This includes metal conduits, enclosures, and equipment. Bonding ensures that all metallic parts are at the same electrical potential, minimizing the risk of electrical shock. NEC sections 250.90 through 250.106 provide requirements for bonding. A neutral conductor is required for all service upgrades. The neutral conductor provides a return path for unbalanced currents and is essential for the proper operation of many appliances and electronic devices. The neutral conductor must be sized appropriately for the calculated load. NEC section 220.61 provides guidelines for sizing the neutral conductor. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning or other transient events. SPDs should be installed at the service entrance and at any subpanels. NEC section 285 provides requirements for surge protection devices. Arc fault circuit interrupters, or SIs, are designed to detect arc faults, which are a common cause of electrical fires. SI should be installed in all branch circuits that serve bedrooms, living rooms, and other habitable areas. NEC section 210.12 provides requirements for arc fault circuit interrupters. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can cause electrical shock. GFCI should be installed in all branch circuits that serve bathrooms, kitchens, and outdoor areas. NEC Section 210.8 provides requirements for ground fault circuit interrupters. The service equipment must be properly labeled to identify its function and voltage rating. This includes labeling the main disconnect switch, circuit breakers, and other components. NEC Section 110.22 provides requirements for labeling. All electrical work must be performed by a qualified electrician who is familiar with the NEC and local electrical codes. Permits and inspections are required for most electrical work. This ensures that the work is performed safely and in compliance with code. Contact the local electrical inspector for information on permitting and inspection requirements. When upgrading to a 200 amp service, careful planning is necessary to ensure that the existing electrical system can handle the increased load. This includes evaluating the existing wiring, panel board, and grounding system. The existing wiring may need to be upgraded to accommodate the increased amperage. The panel board may need to be replaced with a larger one to provide sufficient space for the additional circuit breakers. The grounding system may need to be upgraded to meet the requirements of the NEC. Before starting any electrical work, it is essential to disconnect the power at the main disconnect switch. This will prevent electrical shock and minimize the risk of fire. Always use appropriate safety equipment, such as insulated gloves and safety glasses. Follow all applicable electrical codes and industry standards. If you are not comfortable performing electrical work, hire a qualified electrician. Upgrading an electrical service is a complex and potentially dangerous task. It is important to take the necessary precautions to ensure safety and compliance with electrical codes. By following these guidelines, you can upgrade the electrical service safely and effectively. Understanding the purpose and function of each component in the electrical system is also vital. For example, knowing how a circuit breaker works can help in troubleshooting electrical problems. A circuit breaker is an automatic switch designed to protect an electrical circuit from damage caused by overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Circuit breakers are essential safety devices in electrical systems. There are several types of circuit breakers, including thermal, magnetic, and thermal-magnetic breakers. Thermal circuit breakers use a bimetallic strip that bends when heated by excessive current, tripping the breaker. Magnetic circuit breakers use an electromagnet that trips the breaker when a short circuit occurs. Thermal-magnetic circuit breakers combine both thermal and magnetic elements for comprehensive protection. When a circuit breaker trips, it indicates a problem in the circuit. It is important to identify and correct the cause of the trip before resetting the breaker. Common causes of circuit breaker trips include overloads, short circuits, and ground faults. An overload occurs when the circuit draws more current than it is designed to handle. This can be caused by plugging too many appliances into the same circuit. A short circuit occurs when a hot wire comes into contact with a neutral wire or ground wire. This creates a sudden surge of current that trips the breaker. A ground fault occurs when current flows through an unintended path to ground. This can be caused by damaged insulation or faulty wiring. To reset a circuit breaker, first turn off all appliances and lights in the circuit. Then locate the circuit breaker that tripped and move the handle to the off position. Wait a few seconds and then move the handle to the on position. If the breaker trips again immediately, there is still a problem in the circuit that needs to be addressed. Never bypass a circuit breaker or replace it with a higher amperage breaker. This can create a fire hazard and damage the electrical system. If you are unsure about how to troubleshoot or repair a circuit breaker, consult a qualified electrician. Regular maintenance of the electrical system is essential for safety and reliability. This includes inspecting wiring, circuit breakers, and other components for signs of damage or wear. Replace any damaged or worn components promptly. Keep electrical panels and outlets clean and free of obstructions. Avoid overloading circuits by distributing the load evenly across multiple circuits. Use surge protectors to protect electronic devices from voltage spikes. Have the electrical system inspected by a qualified electrician every few years. By following these maintenance steps, you can extend the life of the electrical system and prevent electrical problems. Another important aspect of electrical safety is understanding the dangers of electricity. Electricity can cause serious injury or death if not handled properly. Always treat electricity with respect and follow safety precautions. Never touch exposed wires or electrical components. Avoid working on electrical systems in wet or damp conditions. Use insulated tools and equipment when working with electricity. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Never overload extension cords or power strips. Keep electrical cords away from heat and water. Teach children about electrical safety and keep them away from electrical hazards. If you witness an electrical accident, call for help immediately. Do not attempt to rescue someone who is in contact with electricity unless you are properly trained and equipped. By understanding the dangers of electricity and following safety precautions, you can protect yourself and others from electrical hazards. In addition to the information provided, it's worth noting the importance of arc flash protection in industrial settings. Arc flash is a dangerous electrical explosion that can occur when there is a fault in electrical equipment. It can cause severe burns, blindness, and even death. Arc flash protection is essential for workers who work on or near energized electrical equipment. Arc flash protection includes wearing appropriate personal protective equipment, such as arc-rated clothing, gloves, and face shields. It also includes following safe work practices, such as de-energizing equipment before working on it and using insulated tools. Arc flash studies are conducted to determine the level of arc flash hazard at different locations in an electrical system. The results of the arc flash study are used to select the appropriate personal protective equipment and safe work practices. Training is essential for workers who work on or near energized electrical equipment. Workers should be trained in the hazards of arc flash and the proper use of arc flash protection equipment. The National Fire Protection Association, or NFPA, Standard 70, provides requirements for arc flash protection. Employers are required to comply with NFPA 70 to protect their employees from arc flash hazards. Arc flash protection is a critical aspect of electrical safety in industrial settings. By following NFPA 70 and implementing appropriate arc flash protection measures, employers can protect their employees from the dangers of arc flash. In summary, upgrading to a 200 amp service requires careful planning and execution. It is essential to understand the NEC requirements and follow safe work practices. Grounding, bonding, overcurrent protection, and surge protection are all critical aspects of electrical safety. Regular maintenance of the electrical system is essential for safety and reliability. Arc flash protection is essential for workers who work on or near energized electrical equipment. By following these guidelines, you can upgrade the electrical service safely and effectively and ensure the safety of yourself and others. When dealing with older electrical systems, it's crucial to pay close attention to the condition of the existing wiring. Over time, wiring can deteriorate due to factors such as heat, moisture, and physical damage. Deteriorated wiring can pose a significant safety hazard, increasing the risk of electrical shock and fire. Common signs of deteriorated wiring include cracked or brittle insulation, discolored wires, and loose connections. If you observe any of these signs, it's essential to have the wiring inspected by a qualified electrician. In some cases, it may be necessary to replace the entire wiring system to ensure safety. Aluminum wiring, which was commonly used in homes built in the 1960s and 1970s, can also pose a safety hazard. Aluminum wiring is more prone to loosening at connections, which can lead to overheating and fire. If you have aluminum wiring in your home, it's recommended to have it inspected by a qualified electrician. There are several methods for mitigating the risks associated with aluminum wiring, including replacing the wiring with copper wiring, installing special connectors designed for aluminum wiring, and applying antioxidant paste to the connections. Another important consideration when operating an electrical service is the location of the electrical panel. The electrical panel should be located in a dry, well-ventilated area that is easily accessible. The panel should not be located in a bathroom closet or other area where it could be exposed to moisture or humidity. The panel should also be located away from flammable materials. The panel should be mounted securely to the wall and should be properly labeled. The panel should be accessible for maintenance and repairs. When selecting a new electrical panel, it's important to choose one that is appropriately sized for the expected load. The panel should have enough spaces for all of the necessary circuit breakers. The panel should also be rated for the appropriate voltage and amperage. It's also important to consider the type of circuit breakers that are used in the panel. There are several types of circuit breakers available, including standard circuit breakers, ground fault circuit interrupters, and arc fault circuit interrupters. Standard circuit breakers provide basic overcurrent protection. Ground fault circuit interrupters protect against ground faults, which can cause electrical shock. Arc fault circuit interrupters protect against arc faults, which can cause electrical fires. It's important to choose the appropriate type of circuit breaker for each circuit. When installing a new electrical panel, it's important to follow all applicable electrical codes and industry standards. The panel should be installed by a qualified electrician. The panel should be properly grounded and bonded. The wiring should be properly sized and connected. The panel should be inspected by a local electrical inspector. Proper installation of the electrical panel is essential for safety and reliability. When working with electricity, it's important to be aware of the potential hazards and to take appropriate precautions. Always disconnect the power before working on any electrical equipment. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. Never overload circuits or extension cords. Never tamper with electrical equipment. If you are not comfortable working with electricity, hire a qualified electrician. Electrical safety is paramount. In addition to the points discussed, consider energy efficiency when upgrading an electrical service. Modern electrical codes and standards often incorporate energy efficiency requirements. This can include using energy-efficient lighting appliances and HVAC systems. Energy-efficient equipment can reduce energy consumption and lower utility bills. When selecting new equipment, look for the Energy Star label. Energy Star products meet strict energy efficiency guidelines set by the Environmental Protection Agency. Energy-efficient lighting can significantly reduce energy consumption. LED lighting is much more energy efficient than traditional incandescent lighting. LED bulbs last longer and use less energy. Smart home technology can also help improve energy efficiency. Smart thermostats can automatically adjust the temperature based on occupancy and preferences. Smart lighting systems can automatically turn lights on and off based on occupancy and daylight. Smart appliances can be programmed to run during off-peak hours. Energy audits can help identify areas where energy consumption can be reduced. An energy audit can provide recommendations for improving energy efficiency. Implementing energy efficiency measures can not only reduce energy consumption but also improve the comfort and value of the home. Consider the long-term benefits of energy efficiency when upgrading an electrical service. Incorporating renewable energy sources, such as solar panels, can further reduce energy consumption and reliance on the grid. Solar panels convert sunlight into electricity. The electricity can be used to power the home or can be fed back into the grid. Solar panels can significantly reduce electricity bills. Government incentives and tax credits are often available for installing solar panels. Before installing solar panels, it's important to evaluate the suitability of the roof and the amount of sunlight that it receives. A qualified solar panel installer can assess the site and provide recommendations. Solar panels require minimal maintenance. They typically have a lifespan of 25 years or more. Installing solar panels can increase the value of the home and reduce its environmental impact. In addition to solar panels, other renewable energy sources such as wind turbines and geothermal systems can also be used to generate electricity. Wind turbines convert wind energy into electricity. Geothermal systems use the Earth's natural heat to heat and cool the home. Renewable energy sources can provide a sustainable and environmentally friendly source of electricity. When considering renewable energy sources, it's important to evaluate the costs and benefits and to choose the option that is best suited for the specific location and needs. Another aspect to consider is future expansion. When upgrading the electrical service, it's important to plan for future electrical needs. This may include adding more circuits, installing a sub-pole, or increasing the size of the service entrance. Consider the possibility of adding new appliances, electronic devices, or electric vehicle charging stations in the future. It's better to overestimate the future electrical needs than to underestimate them. Adding extra capacity to the electrical system during the upgrade can save time and money in the long run. It's also important to consider the location of the electrical outlets. Make sure that there are enough electrical outlets in each room and that they are conveniently located. Consider adding additional outlets for electronic devices, such as computers, televisions, and gaming consoles. USB charging ports can also be added to electrical outlets. The electrical outlets should be tamper-resistant, especially in homes with young children. Tamper-resistant outlets prevent children from inserting objects into the outlets. The electrical outlet should be properly grounded and bonded. Proper grounding and bonding is essential for electrical safety. It's also important to consider the lighting in the home. Make sure that there is adequate lighting in each room. Consider using dimmer switches to control the brightness of the lights. Dimmer switches can save energy and create a more comfortable atmosphere. Recessed lighting can provide a clean and modern look. Under-cabinet lighting can provide task lighting in the kitchen. Outdoor lighting can improve safety and security. Motion sensor lights can automatically turn on when someone approaches the home. Landscape lighting can enhance the beauty of the yard. When selecting lighting fixtures, it's important to choose energy-efficient options. LED lighting is much more energy efficient than traditional incandescent lighting. LED bulbs last longer and use less energy. It is also important to note the importance of complying with all applicable building codes and regulations. Building codes and regulations are designed to ensure the safety and welfare of the public. Before starting any electrical work, it's important to obtain the necessary permits from the local building department. The building department will review the plans and inspect the work to ensure that it complies with the codes and regulations. Failure to comply with the building codes and regulations can result in fines, delays, and even legal action. It's also important to work with qualified and licensed contractors. Qualified and licensed contractors have the knowledge and experience to perform the work safely and correctly. They are also insured and bonded, which provides protection for the homeowner in case of accidents or damages. Check the contractor's references and verify their license before hiring them. Get a written contract that outlines the scope of the work, the price, and the payment schedule. Read the contract carefully before signing it. Keep a copy of the contract for your records. Regular inspections of the electrical system are also important. Schedule regular inspections of the electrical system by a qualified electrician. The electrician can identify potential problems and recommend repairs or upgrades. Regular inspections can help prevent electrical fires and other hazards. Keep a record of all electrical work that has been performed on the home. This record can be helpful for future maintenance and repairs. When selling the home, the electrical records can provide valuable information to the buyer. Finally, make sure that the home is properly insured. Homeowners insurance provides coverage for damages caused by electrical fires and other hazards. Review the insurance policy to ensure that it provides adequate coverage. Update the insurance policy as needed to reflect any changes to the home. Proper insurance coverage is essential for protecting the home and its contents.